Hello guys, welcome back to my channels. So today's video I am going to talk about first law of thermodynamics. So what is first law of thermodynamics and its key points and importance, limitations and basic terms. All those things I will cover in this video. Okay, so let's it start. So as we are familiar with thermodynamics, so this is basic chemistry. Okay, people already have studied in BSc, MSc at 10th, 12th class. Okay, so first we can understand the thermodynamics. What is thermodynamics? Thermodynamics means something's flow of heat, means the energy transfer. So let's discuss the points. So energy change accompanies all types of physical and chemical process happening in this thermodynamics, first law of thermodynamics. And this first law of thermodynamics shows the conservation of energy. That means energy cannot be created or destroyed, only transfer from one form to another. So this is very important. So in this first law of thermodynamics, it tells about the conservation of energy. Okay. So energy cannot be created or destroyed, only transformed from one state to another state. Third point is the total energy of isolated system remains constant. For isolated system, the energy is remain constant. Here the equation of closed system, that is are called the first law of thermodynamics equation, du is equal to q plus w, where du is the internal energy and q is the heat, w is the work. Okay. Now discuss the key points. What is key points of this first law of thermodynamics and sign convention? So key point is here. We'll discuss the internal energy, du, heat and work. Okay. So internal energy, the change in internal energy, it is state function. Okay. The change in internal energy depends only the initial and final states of the system, not the path that taken. Okay. So this internal energy, change in total internal energy contained within the system. If the internal energy is positive, that means temperature increase or depends on this increasing the value of internal energy. Similarly, if this value is negative, that means temperature is decreasing. So now discuss the heat. So net amount of energy that transfer as a heat into the system that due to the temperature difference. Okay. This energy transfer as a heat is due to the temperature difference, and this heat is a path function. Earlier internal energy is a state function, not a path, but this heat is path function. Okay. And here if the heat is positive, that means heat is added to the system, and that process is called the endothermic process. If heat is negative, that means heat is removed from the system, that is exothermic. Okay. Now talk about the work. So net work, net work, sorry, net amount of energy transferred as work done on the system, it is a path function. Earlier one is also path function heat, and this is also path function, but it does not depends like state function. It is a path function. So if work is positive, that means work done on the system by surrounding, that is compression of gas, and this equation shows the work is positive. First law of thermodynamics. And similarly, if work is negative, that means work done by the system on the surrounding, that is expansion of gas, and here work is become negative. So most important things is now discuss the limitation. What is limitation of this first law of thermodynamics? So first limitation is that law only, this law is only apply the matter in bulk, those matter in bulk, not to individual atoms or molecules. This law is not applicable for individual atoms or molecules. Okay. So second point is that it does not explain the direction of a spontaneous process. For example, the flow of heat from hot to cold body sites. Okay. So this first law of thermodynamics does not tell about the direction of heat. Okay. And third point is the feasibility of process. How much heat energy can be converted into useful work. Now discuss the basic terms that mostly used in this thermodynamics. So first term is, so here the basic terms of thermodynamics. So first systems, second surroundings, third isolated system, and fourth closed system, and fifth is open system. So these are the basic terms uh, that we used in thermodynamics. Okay. So I'm not going to details what is system and surrounding, isolated and closed, as maybe you know. So now discuss the processes, types of thermodynamics processes. So here basically we have discussed five process, five important process. First is isothermal process. So what is isothermal process? So if you understand this from first word iso means temperature is constant, same, and last third remaining words is thermal means we are talking about temperature. So temperature is constant here for this process. If the temperature of the system is constant during each stage of process. Second one is adiabatic process. So adiabatic process here we mainly discuss about the heat. So for adiabatic process, no heat enters or leaves the system during any steps of process. Okay. So isobaric process. Third one is isobaric process. So here, uh, if the pressure of the system is constant during each step of process, that is called the isobaric process. Reversible process, a process that carried out infinitesimally slow so that driving force is only infinitesimally greater than the uh, opposite force. That denotes the reversible process. Now talk about irreversible process. So irreversible process, a process which does not take any place infinitesimally slowly. That means this irreversible process does not take any late time, but reversible process, to reverse the process, it will take too much time. But this will not take because this will not come back to the initial stage. Okay. So here is the note points. The reversible process can not be realized in practical because this would require infinite time for completion. Okay. Now discuss the work and heat, nature of work and heat. So whenever the system changes from one state to another, it is accompanied by the change in energy. The change in energy maybe appears in the form of heat, work, light, etc. Here the unit of energy is joules and this work is proportional to this H. And if you remove the proportionality constant, this W is equal to JH. Now discuss the some other relation that is most important, that is Euler reciprocal relation. Euler, Euler reciprocal relations. So this relation exactly tells about the R. We can check the function exactness. The function is differentiable or not, we can check. So the derivation things is here. So if z is this state function of two independent variable, that is x and y, of the system, that is this z is equal to function of x and y. Since z is state function, so differential of z is also exact differential, that can be write as a dz is equal to differential of dz by dx at constant y dx plus dz by dy at constant x dy. We can write also this differential part in mxy dx, and this dz dy we can write nxy dy, where this mxy this and nxy this. Now taking the mixed second derivative, then we will get this third equation, and similarly to take second derivative of this nxy, then you will get this. Now if you compare both 3 and 4, you will get something fifth equations, that is called the Euler Reciprocal equation, okay, which is most important. Del m by del y at constant x, that is equal to del n del x at constant y. Now we'll see, now we understand the this Euler equation by taking some example. So in this example, we'll check the exactness of this differential equation. So the equation is given del z is equal to this 51 x square y plus 47 y to the power 4. This is one bracket del x, and this is another bracket del dy. Now we compare this equation from previous one, equation second, this equation, so you will get the mx and ny value. So this is mxy value, and this is nxy value. So now, so what is our motive? So our motive is to check the exactness. So we'll find the del m by del y value and del n by del x. If both value is same, then we can say that this differential equation is exact differential equation. So here we differentiate this equation, above equation, and after differentiation we will see this equation 1, and similarly differentiate this equation with respect to x at constant y, and this one is with respect to y at constant x. So this thing you have to remember, that m we have to differentiate with respect to y at constant x, as you can see here, del m yx del n xy. Yeah. So these things is you have to remember. Okay. So you will get this second equation if differentiate del and this n. So check both equation give the same values after differentiation, 51 x square plus 188 y cube and this one also same. So we can say that this del m by del y at constant x is equal to del m del x at constant y. This equation is del z is exact difference. Okay, I hope you understood. So now discuss the heat capacity. So what is heat capacity? Actually, little bit I have discussed earlier. Heat. It is a path function. Okay, and now here discuss the heat. Little detail. So heat, that means quantity of heat that is required to raise the temperature of the system from the lower to higher temperature, that divided by the temperature difference. The molar heat capacity C is equal to Q by T2 by T1, sorry, Q by T2 minus T1. Here the temperature difference. As you can see that C is equal to dQ upon dt. As I also know that this relationship Cp minus Cp and Cv in gaseous system, Cp minus C is equal to R. It is most important equations where Cp is the molar heat capacity of the gas at constant pressure and Cv is the molar heat capacity of the gas at constant volume. Okay. Now discuss the most important things, that expansion of an ideal gas and change in thermodynamics properties, how the mm, expansion of gas can change the thermodynamics properties. Okay, so first I would like to discuss isothermal expansion. So isothermal expansion means, isothermal means the process is isothermal process. That means here the temperature is constant. Okay. So now calculate the internal energy dU. At constant temperature, the internal energy of the gas remains constant. That is dU is equal to 0. And now calculate the enthalpy of delta H. Since H is equal to dU, H is equal to U plus PV, and del H is equal to dU plus del PV, and if we expand these things you will get this. At constant temperature and dU will get this. So enthalpy is here 0. Now calculate the work, heat and work. So according to first law of thermodynamics, D is equal to Q plus W okay. So for isothermal process, internal energy is 0. That means Q plus W is equal to 0 or Q is equal to minus W. That in case the isothermal expansion. For expansion, the work done is negative. Work done is negative. That means work is done by the system on the surrounding. Now discuss the work done in reversible isothermal expansion. Earlier I discussed the expansion of ideal gas that change to these properties. Okay. Now I'll discuss the work done in reversible isothermal expansion. Work, you will get the work is minus nRT ln V2 minus V2 upon V1, that is equal to minus nRT ln P1 upon P2. During expansion, the V2 value is greater than V1 and P1 value is greater than P2. But in compression, it is just opposite, that is V2 by V1 and V2 P1 by P2 ratio change. So here new work is minus nRT, that is V1 by V2 minus nRT ln P2 by P1 because of compression. So in compression, the earlier one, first one volume is greater than second one volume. Now discuss the work done in irreversible isothermal expansion. Earlier I had discussed the work done in reversible isothermal expansion, but here is irreversible isothermal expansion. So here the free expansion, the external pressure is zero. For free expansion, external pressure is zero. That is work is equal to minus integration of P external dV is equal to 0. For intermediate expansion, if V1 is for intermediate expansion, if V1 tends to V2 against constant external pressure, then you will see W is equal to minus integration of V from V1 to V2, that P external dV is equal to minus P external V2 minus V1, where P, the pressure of gas, is greater than P external pressure. Now discuss the adiabatic process. So as I discussed earlier, when the no heat allowed to enter or leave the system, that means Q is 0. Q is 0, and according to first law of thermodynamics, du is equal to Q plus W, where if you put Q is 0, then you will get du internal energy is equal to work. Now we can understand the expression of external. So let's this example is 1 moles of ideal gas expand against a constant external pressure of 1 atmosphere from a volume of 10 decimeter cube to volume of 30 decimeter cube. And here we have to calculate the work done by the gas, that is in joules. Okay. So here question is asking calculate the work done, which is the unit is joules. So as it is mentioned that the volume is integer, V1 volume is 10 decimeter cube and V2 volume is 30 decimeter cube, and P external pressure is 1 atmosphere. So we have to find the work. Okay. So as the equation of work for expansion uh, of this irreversible uh, processes, the equation is P external W is equal to minus P external V2 minus V1. So here simply put P external value 1 atmosphere and V2 is 30 and 10 is V1. So after calculating, we will get this value, but this is not in joules. So we have to calculate, we have to change this unit in joules. Okay. So W is equal to this. So atmosphere, 1 atmospheric uh, 1 atmospheric is equal to 10 10 13 25 Newton meter square, and decimeter cube 1 decimeter is equal to 0.1 meter. That means here the unit is here mentioned decimeter cube, so 0.001 meter cube. Okay. And 1 atmospheric is equal to uh, 1 lakh uh, 1 lakh 1325 Newton meter square. Okay, so all those value you put here, you will get something like 2020 joules. So this is all about the first law of thermodynamics, and I hope you understood and find some important things from this video. So if you find important things from this video, so please do like, subscribe and comment. So thank you for watching.